Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in.
Hello, I'm Nick.
Hello, I'm Ed.
And, we don't have John with us today. He has some stuff going on, so he will not be joining us. Last week we kind of touched on, robotics and how they can help in medical, how they can help around the house and stuff like that. We kind of want to bring everything back to the industrial side of the house. Well, maybe not just industrial, but to STEM education and stuff like that, I think. And we want to talk about robots, like robot test cell design and training center layouts. So we want to kind of talk about how you can set up a test cell for your organization, be it a robot test cell, a PLC test cell, and any type of training area that can come to mind that you may have or may need, or anything of that nature. Because every use case for a training cell and training development is just that one step different. I'm pretty sure we could break it up into different types, but we're just going to kind of run with it. And hopefully, we cover some of the stuff that y'all need. If you have any questions on any of this that we're going to cover today, go ahead and throw it in the comment section on the YouTube video, or send us an email or something like that, and we'll be happy to respond to you. So, Ed, when we're thinking about test cell or robot test cell or training area development or layouts, what are you thinking?
Well, I think the first thing that we should do is we have to figure out what the criteria is for the training that you're trying to do. Mm-hmm. So is it we're just trying to teach general robotics? Is it we have a specific application like welding or painting or coding, or is it a handling robot? What is the criteria? So we figure out that's the second thing. The third thing would be, what is the footprint? How much real estate is available for the test cell? Mm-hmm. And then you have to look at the cost. What's the cost and what's the ROI for implementing said robot?
Makes sense.
And so the first thing, like I said, once we figured all that stuff, let's just give a simple example. I just need to be able to introduce somebody to robotics. Mm-hmm. So I have a workforce that I'm trying to transition from being like operator loading the station to I want to take the knowledge that the operator has of how the station works and introduce them to robotics. So maybe we just need something small that sits on a desk. Mm-hmm. And it's a desktop training environment,
like an immersion robot type of thing.
Well, I mean, like say maybe it's a small pick and place robot that they use to pick peels or M&Ms or whatever.
Okay, yeah,
but
makes sense.
It's enough to teach the basic concepts to an operator how
it works.
What a 6DoF robot does.
Yeah, Epson's got one of those, and they're actually really cool.
So that I would start there.
Okay. And, I will have to piggyback on that and kind of ride with you on that one, and the thing is like when I was at Automate, I was able to see some of these smaller pick and place robots, the smaller baby robots, the smaller 6DoF cobots and stuff like that. I myself think that if I'm going to introduce a team member or somebody like that using a small cell training area, like what you're talking about, I would probably go to the use of using a cobot of some sort. Maybe not as fast. Safety is in mind, because safety is paramount when we're dealing with robotics. And this is, I kind of want to jump on that tangent real quick. If anybody ever says that implement a robot in a training cell and they don't give you safety parameters, don't do it. Very bad things will happen very, very quickly. However, you can usually implement cobots in an easier fashion. For example, we see the new Fanuc robots. The new Fanuc 6DoF robots out there now, the big green ones. they're the same size as their industrial counterpart robots. So you have the 200 IC, you have, and all of that. However, those can be easily integrated into a close contact training cell where people can kind of learn that process if they're using FANUC robots. I know ABB has, some sort of cobot. However, it's the tube one. And then I know that KUKA has the KRC3.
So
I think
ABB uses two implementations of that. They use Yumi, which is a robot that has 2 arms.
Yeah. Okay. Yeah. I've seen those.
And then it has the torque.
Yeah.
But there also are sensors that you can add to most robots that give you the same implementation of cobots.
Yeah.
So all that they did was they took the sensors that they use for presence of a human and the torque limitations. So you can adjust parameters in any robot.
Yeah.
To say, hey, if this torque value happens, stop the robot. So that can be done on any robot.
Yeah.
Typically, you're not going to do that on an application where you're looking for efficiency. But if you're using something that's going to work with a human, there are a lot of things you can do, like add we can add scanners, laser scanners. You can add different types of devices, like, hey, if this person doesn't put both hands here, the robot can't
Right.
move.
It's like
so it's two hand. It's a lot of stuff you can do to make that safe.
And to kind of illustrate that, when I was at Automate, Yaskawa has a packing robot that they're demoing, and on the ground below it, when you're walking up to it, it's a yellow, blue, red. No, it was green, blue, red. Kind of ground, and it would be, you'd step on the green, it'd be full speed. Blue would be half speed. Red would be 3/4 speed, and has a pressure plate in the carpet, that sensed where you were at. If anybody's ever dealt with convention centers, I bet that was fun to install.
So actually, I have experience with that before that became what you guys call a pressure plate. We use we implemented.
It's called trapdoors, but
No, so it basically did work the same way you're talking about.
Yeah.
And basically the resistance would change based on where you step.
Yeah.
And like I said, this was back
like
in the late 90s. Yeah, basically. And basically where you step, that would change the resistance.
Yeah,
change.
it was a voltage meter, yeah.
Yes.
Okay.
And then you use like a 0 to 10 or 4 to 20
okay.
milliamps to do other things.
That makes sense.
But
us bigger people out there popping fuses.
Yeah.
We make sure it's efficient. But the thing is, and I hate to keep going on this tangent, but if you're going to build if you're going to be able to test cell, find a safe robot to do it with. The one that Ed was talking about, the pill picker robots.
Yeah.
I'm gonna say this: the ones from Epson, yes, the laser jet people, is pretty awesome. And the thing about that is that little thing, right, is $9,000, brand new. That's on one, but you can get one of their 6 DOF robot arms. That's still in a safe state for 12. It just looks like a regular robot arm. Has the head built in, the controller built into it. But the funny part is you can run 240 on it, you can run 120 on it, or you can run 48 volt on it, which is coming out of the car battery. If you were to put it in a portable test cell, training cell. But that's the end of my rant, I think.
Well, most of the robots we were talking about, small robots that do pick and place. So I give you some background. So I have a lot of experience with ABB robots. I have a lot of experience with FANUC robots as far as pick and place, sealing, coating technology. I have a lot of experience with those, and some machine handling and a little bit of weld. So the thing with all of those robots, there is not a safe robot.
Yeah.
It's a not implemented safe.
Right.
So you have to make sure that the implementation is done, because basically what you should have is some programmable logic controller should be the thing that's making sure that you have that safety with dual chain devices that ensure that no one can bypass those safeties.
Right.
That should happen, period. You should not be able to implement a robot without having either of those things. So those benchtop robots that I'm telling you about, basically the way that it works, you had a small cell that had plexiglass or whatever type of enclosure. So it was in an enclosure, you did the programming, and the robot did everything in the enclosure. So the only time that you interacted with the robot is when you open the door, which had a safety device that was a 2-chain device that couldn't be defeated. So it was hardware and software protected. So once you open the device, the robot was basically couldn't work.
Yeah, like one from like
automatic.
Oishna and
You had
stuff
to
like
put
that.
it in T1. It can be Oishna, it can be SICK. It just any device that's a 2-chain device.
Right.
Keys. A lot of people sell the things you need. So you can go as simple as a safety relay with a 2-chain circuit that physically has to go through, and if it doesn't see a change, so if you don't drop voltage on the contacts, it will not allow you to put that thing in automatic.
Right.
So basically, just a concept that where you cannot defeat the safeties.
Which makes sense. And and I think in that same training area, if we're inside the box training area, I would definitely add in computer stations. If I'm having to train somebody on the programming of that robot,
Laptop, HMI, whatever thing
or
you
both.
want to do. Yeah.
But the thing is that this is where you kind of play the efficiency game. If you're a small mom and pop company, for example, and you don't have, and space is of the essence, right? I would have my robot, small little baby robot, like probably about an ABB 120 or something like that, if I needed to have a 6 DOF robot. Or, if you want to do a Yaskawa Moto Mini, Yaskawa Moto Minis, if you can find them, believe me, you can't. I've been looking. But the thing is, I would have one of those in an enclosure, ready to go, and then I'd have laptops for robot programming employees to learn how to program that robot. I'd have a couple HMIs, some of them bare bones, so people can learn how to either build an HMI, program an HMI, or whatever, something like a blow away, pretty quickly, and a PLC training set, and a PLC trainer sitting there, so people can learn how to do PLC programming, while having this all connected to its own stack and stuff like that, where the robot is safe and available for some sort of operation if needed. But you could take all of that, throw it into maybe a 200 by 200 square facility, or a garage. If somebody had to use a small garage part of their office and stuff like that to teach people, they have the ability to do it. So when you start talking size requirements, I really think that if I'm going to do and the thing is that we focus on mom and pop right now before we go large scale, because large scale is when it gets kind of fun. Is the surrounding peripheral setup, so we make sure that we have training happening all the way around the central piece, which is your robot. And then if you have to do like what you're saying, teach a load station, I have a load station built into the robot set that kind of works through how that process is going to look and stuff like that, if I can build my full cell out.
Well, and then so most training sales are going to be about the size of a garage or fit in a garage.
Yeah.
In general, unless you're like a state funded or a government
University.
funding or a university or something. But in general, so the next step would be you should also leverage the virtual environment. So there are several robot software packages that you can buy. So maybe you can't afford the robot, but you can afford the software, and you can still teach the fundamental principles in a virtual environment.
Yep.
And then if you have the equipment on the floor, you can see if those skills translate from the virtual environment to the real environment. And that's another option that you can do if you can't, afford, or if you don't see the ROI with actually purchasing physical equipment and not having it in a production environment.
And I know you're not a fan of this. However, I'm going to bring it up. is with that. If you buy that software, most companies have a secondary package, which allows you to have a VR or AR type of environment.
It's an option.
So, the thing is now you can have employees, with a headset on, watching that programming happen.
Mm-hmm.
So you can actively train people on mistake handling. So if somebody doesn't do something correctly, it's, hey, this is how I would do this. This is how I would fix it. And you have instant, action for for complete reaction. But the thing is like Ed said, the software, the programming software, the nominal programming software for these robots that will allow you to do offline simulated programming is one or none. It's probably the best it's been yet. And now the thing is you can get that same software in the cloud. So if you have to buy multiple licenses, you can float the licenses between people. Or if you have a training area where it's only laptops, I now have a license, a cloud-based license for every single one of those machines. And if I need to have it on a phone or a tablet so they can watch something going on, I can have that cloud license down to those tablets as well. So, I think the software, what you're saying, is probably your best bet at this point.
So
your cheapest starting point.
Yeah, so I would say augmented reality is definitely a tool you can use in conjunction with, like I said, you can have, now you can project images from software or PC onto a wall, and it can be almost to scale. All those tools should be leveraged, so I don't see a problem using any tool. Maybe generations from millennials to generations from Z, they are more comfortable with technology. So you may leverage that for the people that are used to that type of technology.
Yeah.
But if you need to go back, to real world, you could, use, like I said, you could project it onto a wall.
Yeah.
Almost to scale for somebody that's, say, from Generation X. You should leverage all those things. But I would say the next step after, we said a small scale, we should say medium scale. So
right.
Maybe medium scale is an institution of higher learning. They want to add some type of training capacity to be able to, make the work force more ready. So then you would maybe take it a step further and actually start adding, medium scale robots. So I would say like robots that's, maybe 15 kg or less.
Yeah.
You would maybe use those for like welding application, painting application, palletation, and things like that. So I mean, that would be the next step.
And I think that we've seen a lot of stuff lately with the weld robots. And I bring this up because Weld.com did something pretty cool on this the other day. They actually they've been doing it for years. Is they actually will show the benefits of the automated robot welders and how they support the welder on the ground. Because there's some places and some angles that a regular person does not want to go in. I can I can have a robot do it, and it's not going to complain. But the thing is I think that these new robots now, especially doing welding and stuff like that, is changing the game of education. Because now, as for example, if I stick to the welding, idea, you start as a basic welder, then you go to a pipe fitter, then you go start welding stainless, or if you're going to do that, you're going to go weld for like NASCAR chassis or race chassis or something like that. But you can always come back, so which gives the welder the reason to come back to an institution, gives them a reason to come back and learn more and keep learning and keep that elevated. As they come back and learn the robotic side, they don't have to be robot programmers. They elevate their career every step of the way. And we see that with people that are coming from basic hand maintenance, wrench turning maintenance, to the guys that are coming and learning robotics for the first time, and working their way through that. So I think that having those type of robots in like a technical trade school, or in a 4-year university, is just absolutely paramount for what's being taught these days. especially when you talk about like certification programs and stuff like that. And size, building wise, whatever, it doesn't really matter because these weld robots, they're somewhat compact. But you can put one in the middle of a classroom and teach everybody how to weld on a robot, and then have them come up and one by one program something, so everybody learns.
So basically, like if you go to any, so I've like I said, I've been to ABB, I've been to FANUC, I've been to the actual facilities in Michigan. So I've actually been to other places too, but in general, they basically have a classroom where they do theory, and then they have a practical area where all the robots are in a safe state. So the cells are basically a person can stand in front of it, or two. Generally, it's two people.
Yeah.
2 people per cell.
Makes sense.
And they maybe had 20 or 30 different type of applications. From 4 or 5 robots that were palletization, 4 or 5 robots that were like pick and place, 4 or 5 robots that were vision, 4 or 5 robots that were paint application. So you actually didn't paint anything, but it had a vehicle in there where you can
learn
how to do the paths for painting, and then they had applications for welding.
That's pretty cool.
They also had applications for like if you were doing grinding or whatever. So typically they have these stations.
Right.
So typically, ideally, in a higher institution of learning or technical college or whatever you want to call it, trade school or whatever, or apprenticeship program, they make sales, and then you say, well, hey, I got 2 or 3 sales for this application, 2 or 3 sales for that application, and then it even goes as far as, hey, it's a mechanical. They go from a mechanical breakdown and reassembly, electrical troubleshooting, and how to commission modules inside the robot.
Yeah.
And then actual, hey, here's the software package for the painting, welding, pick and place, blah, 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 palletization.
Yeah.
And then even going into using like the software that they use for offline programming. So like all those things are done, and they actually give you real world items inside the classroom so that hey, this is what this module looks like inside of it, and this is what it do, and we're going to go over it. We're going to explain the box.
Yeah.
We're not going to explain everything in the box, but we're going to explain what goes into the box and what comes out of the box.
And and the thing is, and this is where I'm going to start calling out industry here, is if you have a trade school or one of the robotic schools, ECPI being one of them, any of the technical colleges nearby, near your institution, and you are pulling employees from there to do your robotics, sponsor them. Reach out and see what they need. Because the thing is right now they get very little funding. They might be state funded, however. Well, ECPI I don't think is. But some of the technical schools are state funded, however, on some programs, maybe not so much. So they may not have the most up-to-date stuff. They may not know they need the most up-to-date stuff. Send a rep to these schools and work with them to make sure they have what they need. Because the thing is if we're not preparing the next generation of people coming out of these schools with the most up-to-date technical information, we are setting them up for failure from Jump Street. So that's just my rant. My rant is get out there and help these guys. Don't sit back on your laurels and go, oh, they'll come to us eventually. No, they won't. Everybody's going to start thinking this is right, but I'm using software that's 4 years old, 5 years old, that may still be very valuable for some people. However, if you're going to newer organizations and stuff like that, it's not the newest technology. It's not what they're looking for. Now we have a problem.
So
And for me, that's a moral dilemma. For me, if you are an owner or a rep for these companies, robot companies or whatnot, that's a moral dilemma where it's like I need to make sure the people who are going to replace me are trained to the point where they need to be. And the thing is that's why, I love the technical universities. I did the 4-year route. At this point, doing like the 15-year route. But the thing is everywhere I look, the technical schools are making a difference. They're coming in and they're swinging way above their weight class. However, they're the most underfunded, underutilized organization on the planet. And, we need to support them. And I think that if we give them the ability to do that, where they have robot cells for everything they need, because some don't, I think that would be the most opportune thing. But I think that honestly, if you're gonna offer a robot program at a trade school, you should have a building dedicated to that. You should have a warehouse space dedicated to nothing but robots. You have a classroom attached to it with a glass front so you can look out and see the robot sitting there while you're going through theory. That stuff to me is what needs to happen. Every school needs that, where they can look out and see the robot sitting there. They're looking at theory. They see their next step. They can see how they progress. And if I need a welding area, I'll add a welding area. But the thing is they need to see that progression. And I think having a building where, if anything, have it sponsored by these guys. The big three, big four, robot manufacturers, because that's where you get your people from. And also offer certification courses at the Trident School, at the schools. Don't make it where everybody has to come through you. Because the thing is, if you can certify these guys when they come out of trade school and out of tech school, guess what? They come to the workforce faster, they come to the workforce better, and they come to the workforce more eager to apply their trade.
So, just a little clarification. So, unfortunately, with industrial and say commercial, it's a little bit different. So, commercial, you can see things change in 24 months. In industrial, generally, robot platforms they spend probably about 5 years prior developing, but it's normally a 10 to 15 year
ROI
lifespan.
Yeah.
So you don't see a new robot every 5 years.
Right.
You don't see a new platform. You might see some tools, so in general, that doesn't exist in industrial. They have generally like in a weld shop, maybe it's 7 years. Generally in a paint shop, you're talking 15 to 30 years. Assembly is a little bit different, but I'm saying, so generally those things don't change.
Right.
Like, for example, you have, let's look at Allen Bradley. Allen Bradley went from PLC 2 to Slick 500s, PLC 5s to Control Logics.
Yeah.
Siemens went from 5 to 7 to the 1500 and 1200 platforms. So that's 4 since Siemens has started in programming. They purchased Texas Instruments platform and developed theirs.
Right.
So I'm saying that unfortunately the technology doesn't change that much between the hardware.
Right.
It's a little bit of a change between the software based on, what, maybe, AI is the thing now. So now we incorporate some AI stuff. Back a few years ago, vision was the thing. And so that's basically what you see change. The problem with the certifications is most companies do not want to relinquish the quality control they have. When a person comes through their thing, they can say that this person is certified, especially when they're saying that, okay, hey, you Siemens certified. No, I'm just saying, here's the challenges.
Yeah.
They have to get past, that's a cash cow.
Yeah.
For them, training is a cash cow. So to give that to a university, it has to become an economical thing, whereas an ROI thing with them. Because at the end of the day, most industries, that's why you have the problems we have with industries. Like, for example, that's why you have problems with people not having the knowledge of FortiGate.
Well, the thing is to solve the issue with the certification problem. If I'm going to train a certification organization, I'm going to train the trainer. I'm going to train you to train my people, who now are going to have to pay for that exam fee for me to send somebody to your organization once a month to do the test. Guess what? Now I'm making my money back, because most of the time, here's looking at you, Cisco, is that cost of that exam costs just as much as a training course that you would have gotten through that organization.
So they're getting $5,000 a class in most classes. I'm just telling you because
Yeah.
I've been through these classes for Allen Bradley, Siemens,
Yeah.
and I know they're getting $5,000 a class, and you're doing a minimum of 4. That's $20,000 that they're getting. Why should they? I'm saying they have to change their mindset, but I'm telling you the challenges for us, like we're saying, why are we not doing this? Because unfortunately, we live in capitalism, and people in capitalism don't look at what's best for the industry. They look at what's best for the bottom line. So yes, you're right. It can be done, no problem. The people that we're trying to, get to help us have to make the change.
Yeah.
They have to partner with these schools and do this. Like what should happen? All certifications should be agnostic, just like CompTIA.
I agree.
Just like the CCNA.
Yeah.
It should be, hey, here is the standard for all robot certifications. Bam.
Yeah.
And
If you want to
need-
specialize, go to the organization specialized.
Yes. If you want Cisco, then you go to Cisco to get Cisco. But in general, if I want a guy that knows to verify that he has general robot information, general robot knowledge, then that should happen.
Exactly. And the thing is, this is where it gets into with that all three major brands, oh Lord, need to get together and actually come to the table and say, hey, guess what? Let's make a curriculum to actually do a robot certification for all robotics. Have them come together. This is the best practice from KUKA. Here's the best practice from FANUC, best practice from ABB, and best practice from Yaskawa Motoman. Have them come together and say, hey, guess what? This is what we think should be taught. They teach it, at the universities or technical schools, and they can take an exam and be certified as a robot specialist or a robot engineer or something. And then if you want to specialize in KUKA KRC robots, you can go to KUKA and take the KRC class. Or if you want to go, be specialized in, Motoman, you can go to, Yaskawa and do the certification through Yaskawa in Ohio. Or you can go through FANUC, or you can go through ABB, or you can go through any of these guys. But the thing is all of the organizations need to come together and have a common understanding of what they want to teach. Sometimes you get it where it's like, hey, teach this. Okay. Well, that doesn't translate from one robot brand to another because something's done differently. And so it's kind of a headache. We understand that the software on all robots is different. We get it. The teach pennant on all robots is different. We get it. By the way, if you can standardize that, please go ahead and do that.
They tried with symbols and it went horribly wrong.
Yeah, but now everybody has the APK for the tablet. Why don't we do that?
Yeah, it's not happening. it's like trying to get Apple and Android to agree on something. So it's not happening. I mean, I think you touched on earlier. We was talking about augmented reality. We talked about tools like offline programming, simulations, software as a service, and things like that. So I believe what they should do is do more web-based for fundamentals.
Yeah, I can
and
see
offer that for free.
Yeah.
Siemens does that. Siemens does a really good job of that, offering a lot of.
They do a lot of stuff on YouTube too, don't they?
Yeah, but I mean, you can actually take computer-based courses for free for basic electrical, mechanical things like motors and motor controllers and some of that stuff.
That's pretty cool.
They do their basic stuff, and then they even offer some of the stuff like basic programming. So I think that's something that everybody should do. I understand that like I said, capitalism is a big thing in America, and I don't have a problem with that. But like we were saying, you have to be able to, I would say, replenish the workforce. You have to establish guilds. We got away from guilds and apprenticeships and stuff like that. So since we don't have those things, we should have those things in place.
Exactly.
We should openly offer those type of things to people, and then more specialized things. Okay, then we can get paid for what we know.
Right.
Like I believe companies should get paid for all the groundbreaking work they did to get where they were. But if you're trying to get people to be, you need a hook. So the hook should be, if you want to do it this way, offer a portion of your stuff that's basics for people so they can understand robotics. And then you can show the company by saying, hey, just have your people do this computer-based training. Or if you don't want to do it that way, look at companies like Udemy that's leveraging a company-wide subscription
or Skillshare
for training. So look at those type of things. You're only going to help yourself by exposing people to your technology. Holding the technology in and say, hey, I just want to compete with these other people. You should compete when you're trying to do robots on the floor to show what the ROI is to a company selling something.
Yeah.
The
Can't
educational part should be, hey, we need more people. We need more robot programmers. We need more people to fix on the robots. It's only so much AI is going to be able to do, and it's only so much robots going to be able to do. And here's a news flash. It ain't coming for another 20, 30 years.
Yeah.
So you're going to sit around and wait for 20, 30 years to get more money? Or are you going to take this opportunity to get involved with STEM? You guys, and Alan Bradley, Siemens, KUKA, Yaskawa, Fanuc, Motorman. I mean, all of these Epson, all of you guys with these cobots and whatever else. It makes zero sense not to invest in putting these systems somehow in these programs in your community. You should at least adopt a educational area in your state.
Yep.
If your footprint is in Texas, then you ought to have a footprint in the STEM of Texas. South Carolina, Ohio, Michigan, California.
The only company that I know that's doing that is Yaskawa. That's it. The only one that's pushing the envelope of STEM-based training right now and training cell design is Yaskawa. And the team that they have at Yaskawa leading this, I know them personally. They're awesome. The folks that they have in that office that is leading and making sure that some of the training is the best it's ever been coming out of Yaskawa. Those guys are awesome. And one of these days, we're going to have them with us to talk and have this conversation. However, we're going to have this conversation at Yaskawa in Ohio. We're not going to have that conversation over the web or the dining room table. We're going to have the conversation in Ohio at Yaskawa and sitting down with these guys and going through that process. Because they're the ones I know that are pushing the boundaries of making sure the training's happening. Siemens, I know, is getting on board. A couple of, like what you said, with Siemens with the CBD stuff. Also, I see a lot of people posting stuff on YouTube. A lot of companies are releasing small tidbits on YouTube. But if, come out with a package, a training cell package that people can purchase for their organizations. If they know these guys are very passionate about, and also let me go backtrack to Yaskawa real quick. They specialize in making sure that we have STEM education all the way down to our elementary schools with robots. What are y'all doing? However, the thing is if you are a robot company, you're one of the top 5, offer a package where I can walk in. I can say, hey, I'm an organization, I need to order a training package from you. A training cell package. That is your robot safety fence, PLC stuff involved. It can be a heavier weighted package, so it can be expensive, yes. However, if you know that you're going to go with that company, have them. And then have your CBT training where people can take CBT training for free and then still have your robot cell on site to people to do hands-on training when it's time to do hands-on. And here's the thing. when I did government contracting, we also had MTTs, mobile training teams. So we would fly to every location and we'd give computer training. And the thing is we would fly our equipment with us. We'd send our equipment out ahead of us, laptops, system user manuals, system administrator manuals. We'd send all that out ahead of us, and then we'd fly in, do the training, pack our stuff up, and leave.
So, and they do something similar to that with all the ones we're talking about.
Right.
So it's something similar. And you're right about what you're saying. I think maybe one of the solutions is we need to make robots as a service.
Yeah.
They need to figure out how to get this spun up in a container so that people it's affordable to use Robot Guide. Robot Guide should become Adobe.
Yeah. Just not Java.
They have the wrong ideal for this software.
Yeah.
The software you should give we should give the architect the canvas.
Makes sense.
Charge for the hardware. And you can have a limited package for people that's just trying to learn how to use the software.
Right.
You should have a demo version. If you don't want people to give a demo version and not this 30-day, 90-day. Give a demo version that allow the person to do everything except for like commission a robot for a company. Mm-hmm. They should just be able to go through the steps to be able to learn how to do these things. For example, with robotics, and most people don't understand this with robotics. Robotics, I'm going to give you a really, really simple explanation what robots are. Robots are axes, sensors, and then PCs or brains.
Yeah.
That's the robot.
Something's got to convert the ones and zeros.
For example, you use coordinate systems, you use joint coordinate systems, you use tool coordinate systems. Each of these things are from a different perspective.
Right.
The work object has its own frame. The work envelope has its own mechanics. So all I'm saying is these things with the technology we have today, it's not that complicated to have somebody to make I would say like you do, not as much now, but we used to do, you would go to a car lot and pick a car up and drive it and say, hey, yeah, I liked it or don't like it. Mm-hmm. Well, you should have a drive-by experience for your technology. And don't limit it far as how long the person can use it. Just say, hey, I'm only giving you these features.
Right.
You get these features in basic. You get these features in pro. You get these features in enterprise. Here's our thing. Here's the line. Mm-hmm. This is a subscription. You can have a subscription per month or a subscription per year. You can have a subscription per month or a subscription per year. Subscription per month per year.
Yeah.
I don't understand why you don't take the initiative. To me, what's wrong with capitalism now, and I'm not trying to get into politics, is we've lost what capitalism is. Capitalism is not cornering a market so that nobody else can have growth. Mm-hmm. Capitalism is, hey, being able to be the most prosperous you can be because of what you presented as a product or what you have as knowledge and so forth. But the way you keep that going perpetually, so to speak, is that you invest back into the group of people, the consumers.
Right.
You give the consumers tools or give them a experience so that they want to do more. That's why Apple is where Apple is. It's because of the experience you get with an Apple device.
Mm-hmm. And the thing is you brought up the robot as a service, and the stuff like that, in which I still don't understand why I can't buy ABB Robot Studio and pay a monthly fee for it. Can't quite figure that one out. But still, I digress. We have, I can't remember the name of the school, and I think it's in Alabama that does the STEM semi-truck. So they bring
AIDT.
Yeah, AIDT. They do the semi-truck with all the robots and stuff like that, and they teach kids STEM, right? You have these organizations that build shooting ranges in the back of quad-cons. Why can't I take a 7 cube or an ultra high 7 cube or a quad-con that usually I use for an office anyways and convert that into a robot cell that if a customer needs that robot to do demoing and testing and all this other stuff, I drop the robot off, they pay a fee for it. When they're done with it, I pick it up and take it back with me until you want to buy a full-fledged robot to have installed in your location.
What are they doing at trade shows? How's that any different taking a trade show exhibition?
Right. At trade shows, you put everything in a box and ship it.
No, I'm saying
yeah, exactly.
It should work the same way
Yeah,
they send
exactly.
robots to an exposition.
Yeah.
They should be able to do the exact same thing you're saying.
Yeah. Drop a 7 cube. If you don't know what a 7 cube is, it's a square quad-con. If you don't know what a quad-con is, it's a seaborne shipping container. Throw a robot in the middle of it, have a PLC in there, have it all contained. The only thing you have sticking out the side is a plug. Ding, all right, we got power. And let there be light. We got Einstein. But, the thing is, and you have, all the horse torques you could possibly want and the Einsteins you need. But the thing is, and if you don't need it for more than 30, 60 days to demo a robot that you need, you can send it back. You would be surprised how many robot arms you find on YouTube, on Amazon, not on Amazon, but eBay, which I can find them on Amazon, on eBay, that says, hey, I only had to do this from implementation, and now I have to turn around and sell it. Guess what? Now you stuck these people with inventory. I get it. Some companies are more hard-headed than others. You might not try to, I need to add another robot arm to this. Let me make sure it fits. Okay. Why don't you have a robot arm that's inert? And let me ship you an inert arm to make sure the damn thing fits. You can already 3D print the end effectors. Why do I need to have a robot that works, that coming in and being dropped into a station to make sure it fits? Why am I paying for that? Like you said, a robot as a service. I should have integration robots available and ready to be picked up in a container, brought to my site, demoed, tested, trained on, then sent back to the manufacturer for when I buy a real robot. And if I need a trial robot to add to my stations to make sure it fits, I should have an inert robot that comes as my commissioning package, that once I'm done with that inert robot, I pack the damn thing up and ship it back.
Yeah. I mean, that's an idea. Like say, I have a little bit of intimate knowledge on how that works. So basically, you go through a process and you both sit down and you figure out what your criteria are. They tell you what they can do and can't do if that technology does not exist. Say some end effector that has not been created for some unique product that you have to manipulate, then they'll work together with you to develop that with CAD. Normally it's SolidWorks or something like that.
Yeah, the industry standard.
The Lima is one of the
Domia.
CATIA is another one. But the problem is they do not generally want to keep inventory. The only one that I know of personally that I've been to is that most of the construction of the robots for FANUC, when it comes to the handling, welding, and so forth, is done in the States. ABB, generally most of their stuff is done in Norway, Sweden, and now some in China. So they have some restrictions, and they don't typically keep a lot of inventory as far as complete packages at these places. So it's probably a just-in-time thing, which is a good thing that the Japanese introduced.
Yeah.
But I think sometimes we get too rigid with concepts that were created 20 to 50 years ago. I mean, some of us still use Excel sheets to emphasize, to show data.
Right.
This is, to me, Excel sprawl is a thing. Excel should go effing away.
Yep, I agree with that.
I mean, should be able to use Excel, but as far as Excel to track something, are you kidding me?
Yep.
I mean, it's the same thing with the robots. Unfortunately, we spent a little bit of time on this, and we would like to see these things change. I challenge any of these companies that want to reach out to us. We will work with you, and you don't have to send us anything. We will work with you and try to get you in touch with some of these institutions of learning where you can get these things established, so you can have your own guild, so that you can perpetuate the people with the knowledge to how to use ABB robots, Fanuc robots, Siemens, and Allen Bradley controllers. I mean, the greatest thing that I've seen over my career, and I've been doing this since 1992. I am so proud that Arduino has produced a PLC. It just
you're going there.
It makes me feel so good that something was based off education. Now it's taking that education that they gave away for free, help people build, and now they're moving into the industrialization of their concept.
And y'all, let me tell you, I laugh at this because I saw this controller. I had the opportunity to talk to some of the lead engineers for the Arduino PLC at Automate. I had the opportunity to sit down with these guys, get my hands on it, play with it, learn about their PLC engineering core, a certification course that's coming, that anybody can jump in on with these guys and actually be certified as an Arduino PLC programmer. You know, and the first thing I did is I grabbed my phone and I started texting friends. I said, "You won't believe this." You know, most of the time I got a head scratch and, what are you talking about? You know, that was the first, I think, 4 things I got from one of them. One of those people being Ed. I said, "Hey, Arduino is coming out with a PLC." Huh? I had to look at my phone real quick, make sure I wasn't waking him up. And it's like, no, seriously. What? Picture. Send. Oh. And because no one knew they were coming. They held this in such tight secrecy that it's like, hey, guess what? We got a PLC now. Congratulations. And now you can go through plccables.com and actually buy one of their trainers that they have. Or you can contact us and we'll build you one. But the thing is now they have the Arduino PLCW. Is the Wi-Fi PLC. I have been told, and this is kind of let the cat out the bag, I have been told that if I'm going to buy any version of the Arduino PLC, buy the Arduino PLCW. The reason is Arduino is already planning over-the-air programming for these PLCs to allow you to do it without being connected to the device.
I mean, you can. I think Siemens actually can do.
They want to. They can't.
Yeah.
However, Arduino wants to do mobile. They want to figure out a way where you can do this web-based and not connected on the same net. You can be on the same Wi-Fi network to that device. You can Wi-Fi right to it, and it's direct contact. So they're pushing the envelope of these things. It's now called Arduino Industrial, or no, Arduino Pro. Arduino Pro.
I think it does say industrial.
It does.
In that advertisement.
And it's always going to be under the name Arduino Pro. Arduino Pro is the new, darker brand of Arduino. They have more IOs. They have more things. And the thing is if you look at their PLC and you say, "Oh, I don't think that's going to work. That's not enough IOs." Guess what? You can add an IO module.
Yeah. So it's equivalent to the 1200.
Right. Exactly.
It's equivalent to the S7 1200. It's equivalent to the Opto 22.
Yeah, and
it's
easier to
equivalent to the Micrologix 800.
Yeah.
500, 800 series.
And it's easier to program.
Yeah.
And the reason why I say that, and I know there's going to be some PLC purists out there that are, no, it's not. Because you can still use SCL. You can still use ladder logic if you really felt like it, if you really want to be special. If you kind of, hurting for that. You can still do FBFC programming if you really want to go that route. Or you can open up the Arduino IDE and just throw your code in there and send it.
Yeah.
And guess what? That's easier. If you know how to program an Arduino, you know how to program a PLC now. So everybody who thought that I can't be a robot, I can't be a PLC programmer. Well, guess what? We have something for you. It's called Arduino.
Yeah.
Go take a look. And now you have, the industrial Raspberry Pi PLCs now that are out now.
Yeah.
So you can get your hands on those things too. Yeah, I haven't really played with them too much.
So like the programming language, it's a reason why ladder logic's not going anywhere.
Right. Industry standard at this point.
Well, no, you have a mechanic or you have a electrician that's normally the guy that's interfacing with the PLC.
Yeah.
So you can do everything you say with Python. You can use Python right now in other languages in Step 7 and in Allen Bradley.
Yeah.
This is nothing new. I mean, they've had this capability. It's just that the industry has never transitioned over to that.
Yeah.
You can make these the same way you make FCs and say, add-on instructions in Allen Bradley, FCs if you're talking Siemens. So basically that's code that consider those like DLLs.
Okay.
You don't necessarily have to know what's going on in the DLL. You just have to know that, hey, the DLL is the library that this executable is accessing.
Makes sense.
So you can still basically have your primitive instructions, which would be ladder logic, so that the tech can troubleshoot.
Yep.
And then the things that are happening in the FC, hopefully you're not doing anything that's primitive in the FC. You're doing complicated things like mathematical calculations, data manipulation. Maybe you're doing some IoT, MQT stuff, or maybe you're doing maybe you got a recipe set up. Okay, well that's not necessary to see. We just need to know when it doesn't work.
Right.
And then basically it should be like the black box. Here's the ins, here's the out. You got a problem with the ins. Reset the ins. Hey, you got a problem with the out. Hey, you got to reset the ins or the out. So whatever you have to do, you should make your FC robust enough, make the library robust enough that if there's an issue, there's a way to reinitialize the command to go to the library to say, okay, or you can restart that process to go back through. And if it's a bug in the library, then you should hopefully, if you're using Python, you understand error handling.
Yeah.
Please understand error handling. And not just, user error handling. Your own programming error handling.
Yeah.
Input, you should have input validation and these type of things. If you're using Python, Java, whatever thing you're using, what is it?
.NET.
Pound C.
C#.
Yeah, C#. Whatever you're using, you should, be leveraging those things.
Just because it looks like it works does not mean it's always going to work.
Yeah.
The thing about PLC programming is not like programming anything else where, oh, look, I got bugs, but it still works. Yeah, no, that won't work. Let's leave the buggy code to HTML and your websites that you're building at home, to stream your video game service on. Don't put that in the PLC because the PLC will freak out. It won't know what to do.
Well, I give you a perfect example of what I mean by something that is unintentional.
Yeah.
Using the wrong structure.
Oh, that'll do it.
Hey, I used the dent when I should have used the reel. If you are using a certain area in the memory, you better make sure that you allocate it for the right type. Don't use a dent if you need to use a reel.
Yeah.
And worst case, you can use the reel and it still covers the dent.
And I'm only using the first half of DB and I'm going to pre-program for the last half. And it's one of those. It might work. 50-50 chance. Something will, come around eventually. But, the thing is that's also stuff you can add to your training cell. I know we're kind of going over a little bit of time here, and I really don't care. Is the fact that add in sloppy code to your training cell. Have somebody troubleshoot it. Add in broken code. Have somebody go into your training cell and break it. And then have your tech, who's going to be your gung-ho tech, because everybody's got one, to go in there and have to fix it all. And then if they can't fix it, guess what? Cool. Now they're small spots because some dude behind them who may not be, or gal, may not be the gung-ho guy. The gung-ho person may come in there and fix what they were looked at, because guess what? They didn't see it. They were too full of themselves or something like that. We all have one we work with.
So I think the problem with training, when we say, hey, I'm going to put a landmine in here and I want you to find it, I believe in buggy code, but I believe in buggy code in concepts.
Yeah.
I'm trying to teach you a concept. So like when you learn Python, and I highly recommend it's a book that's called Automate the Boring Stuff. One of the best books ever for anybody that's a system administrator or just a teacher, or you're a manager or engineer. You're not trying to, become a programmer, but you want to automate some things that you have to do manually. Mm-hmm. So what I believe about what this guy promotes is buggy code, but with concepts,
right?
Frameworks. So I should give you a framework of something that's buggy code, that's input validation. I didn't set parameters for a person where they can put in numerical information where I only want letters.
Right.
So I should be able to have exception handling to say, well, no, you have to enter this. Mm-hmm. It should not be a case where I can put in something into SQL injection, people. I shouldn't be able to inject something that's going to crash a program in a PLC.
Yeah.
I should protect for that as much as I can. I can't protect for every case because this is not possible.
Right.
But I can at least say, hey, I want to validate the input that's been put in here. I can at least say, hey, when I move this data here, it's the right type.
Right. That makes sense.
Just things like that. Or the other thing is the buggy code could be, okay, here's a buggy code with this type of problem. Case 1, case 2, case 3, case 4, mm-hmm. case 5. And it should be the same buggy code until you get to a point. Then we can start adding the landmines.
Yeah.
After you teach the frameworks and they get used to seeing different type of codes, because even a person that defuses a bomb goes through scenarios of different type of triggers that's in that bomb.
Yeah.
I believe the same thing that we do in, say, bomb disposal teams, the same thing we do with military exercises, where you go to, if you're in electronics, you go to a school, or if you're a mechanic, you go to a school and there's a live mock-up mm-hmm. of that thing you're working on. Yeah. I think those should be things that you should incorporate into your test cells.
Oh yeah. It's built to be broken. It's wargaming it. How do I wargame production? Production will always break something. However, I need to have something in my test cell or test cells that allows my techs to learn how to to master breaking down a robot quickly, and breaking it down and putting it back together and making sure it works without just having to rip it out the cell and put a new one in. Or how to change a gripper out quickly. That may be a problem. Or troubleshoot something. That's the connection on the end of a gripper. The actuators, but also like a faulty HMI, that may have something going on with it that somebody needs to replace, swapping it out, that just swapping out the hard drive and making sure that you're on the same IP address subnet and stuff like that, that type of stuff, basics to keep production running. And then if we want to get into, like you said, the buggy code, and it's, hey, guess what? We're not going to set the landmine for you, but we're going to give you a scenario, and there you go. Like what we were saying, it has to be scenario based. That type of stuff is paramount, because always reemphasize the training portion, always. And the thing is make it on a switch. So make it where, hey, I want to go do training on this. Okay, cool. Let me go upload this program to the PLC and the robot for you, and you can go train on it all day. It's ready to go.
I would even go further than that. I would program, say if we're saying we're using the same manufacturer.
Yeah.
Same manufacturer that we purchased for this sale.
Yeah.
I would have it to where I got an HMI. So I would incorporate gamification. The guy could basically click on the icon on the HMI.
And it already does things.
And that's this module. You can click on another thing on HMI and it automatically loads this, and
Yep,
so forth.
makes sense.
Especially if we saying we go into robots as a service.
Yep.
That it's easy to spin up different virtual machines.
Yeah.
So I believe that's what we do in basically all of our environments where we're using computer technology. Hey, I need to run this on Linux version X.
Yep.
Spin up the virtual machine. Hey, I need to run this on the Raspberry Pi, blah, blah, blah. Spin up a virtual machine. I need to run it on OS X. Spin up a virtual machine. I don't have to have that physical equipment for each one. I just have to have a server that has the capacity to spin up several virtual machines containerized.
Yeah, makes sense.
For cost saving.
Exactly. And make it compactness too. The thing is then instead of having an entire cell, you've got a laptop.
Unless you want to,
Server.
like you say, tear down
Yeah.
the robot, you should have an area to
Right.
tear down the robot, do electrical, blah, blah, blah.
Yeah.
Hey, I need to replace this. So that's called fire drills. So each manufacturer or each company should do fire drills. There's a reason they do fire drills on the submarine.
Yeah. And the thing is don't open the hatch. You need to do also, like you said, the fire drill on, hey, what happens if I lose a controller? How do I reprogram this robot back to square one?
How we replace the whole controller. How we
Right.
replace the whole PLC.
How do I go back to station? How do I go back to zero? What I mean by that is I took a cyber hit. Now all my stuff is wiped out. How do I reprogram this thing from Jump Street?
What's the recovery program?
Right,
Do I have
exactly.
an image?
You should be able to test disaster recovery inside your test cell. Your test cell needs to be where you test that. So when you build your test cell, build it offline, just in case something does happen to your manufacturing facility. It doesn't take down everything,
Yep.
and it saves your test cell because your test cell may have some sort of code on it that may at least get you started.
Yeah. So you should have a cold site, warm site, but
Right.
you should have some type of recovery backup plan that takes your data. So every company should have either a digital twin or somewhere that they have hey, worst case, I can spin up a cold site. Hey,
Right.
worst case, I got a warm site that's running. It's just switch it over.
And I think that holding on, especially when you talk about like on-site warm site type of setup, if you're going to do your warm site on premise, highly say don't do that, but it's possible. Make it where your test cell has access to it, because the thing is, say I have an issue with the same exact robot, same exact PLC, same exact controller at station 2. Station 1's running fine. I can download the program for that station, download the robot program for that station, and now I have an exact replica of what is going on my cell, so now I can troubleshoot my cell without stopping production. So production is still running by a buggy, but now I can come in and I can see, okay, cool, is it an issue with the code or is it an issue with the robot itself? Because now I have a duplicate copy of all of my code, my entire robot program, robots running the same exact auto program that they would be on the line. So now I could pull that back. So that's also a good reason why your test cell should always have access to your code, because you might need to bring it down. But the thing is make sure you can sever that line pretty quickly. So if anything, have your hot side attached to your robot cell, that in case of a disaster recovery, I can sever that communication. Meaning that now all of my robot code, PLC code, and all that stuff is within my test cell. Have my test cell my safe,
Yeah.
inside the location, because now I have everything I need to bring everything back online. And that test cell may save you if you have to go down some, because I can retool my test cell pretty quickly, and I can run, if I got to run parts, I can run individual parts.
So you definitely want a mitigation strategy. So partner, you want to build your lines as best as you can so that I can utilize technology from either side of a line. I can utilize technology by maybe one robot does more utilization,
Right.
and the other one does less. The one thing I would add to, if you were going to do a connection to your test cell, I would do a one-time access. So my thing would be, hey, it only needs to go and connect to the warm site when it needs to pull those files.
Yep.
And
I heard
only
that.
when it needs to archive those files. I made some changes I want to archive. I would say maybe you had some intermediate system where the test cell is segmented and behind some type of firewall both sides. You can have a DMZ, so to speak, and that code could be put there. We could use some type of enhanced technology, far as we can go through and use different devices to verify that we don't have any problems. So AV, we can do some things with monitoring and stuff like that, DLP, stuff like that, to make sure that nothing's going on with the data. And then you just send it to, basically send it to the DMZ, and then the firewall said, yes, everything is good. Our next gen firewall checks everything. Our system for monitoring checks everything. The AV is satisfied. Now we can send it to the next side of that. It comes through. We do it again. We scrub twice.
Yep.
You never scrub once. You scrub twice. And after a second scrub, if we missed it, then hey, you a good one, Mr. Virus Guy.
Yeah. You won this time.
Yeah.
So it's, best practices, y'all. That's what we're trying to preach, is best practices. What we think is best practices. Some of y'all may have different ones. If you do, let us know what they are. We want to hear it. And also, and this is kind of bringing us to the end, but if you have a training cell at your location, let us know what it is. We're curious, because we don't know what everybody's got. However, we can tell you what we think you should have, or what should be out there, or what should be available. And it's the same thing when it comes down to training software. Let us know what you're playing with. We want to know. We're kind of curious. Hopefully, we'll be able to help you out soon, with everything we got going on. So, I just want to take the time also and thank every single person who's ever tuned in to, well, I guess you could say listen to us ramble, across the globe, because we've had, kind of an upkick and, people listening. We've had people listen to us on YouTube and stuff like that. We're at 2839 overall. We never thought we'd get past 3, and, well, those 3 were friends. But, now we're global. We're all over the world, and we can't, and the thing is we wish with every ounce that we could to say hello to every single one of y'all, to meet y'all, to have conversations about why you listen, and kind of get an idea of what you learned. That's what we always say, keep learning. Go out and take a look at vulcanara.com. Go take a look at the YouTube channel. Leave us some comments on there. Like some stuff. I see some likes on there. Stuff that we've been posting. Been doing a little bit more headless content for a little bit. And subscribe to the YouTube channel. We would love it if the 2,839 of y'all that are listening to us on the podcast would go listen to us on YouTube and hit that subscribe button over there. But also take a look at Printed Heritage. Go take a look at the blog. We're going to add more stuff to the blog soon. So get out there. Take a look at the stuff that we got going on. Hopefully we can help you. And then hopefully we got more. We're gonna have more stuff coming soon. There could be a chance that if you need a PLC trainer, we may be able to help you out with that and stuff like that. So we're kind of aiming that way. So what I say, thank you to every single one of y'all. Get out there, learn something, have a little bit of fun with it. So y'all have a good one, and I'll talk to you later.
So like Nick was saying, I appreciate all the support. Basically this is a passion for us. It started out as basically a joke. It's like, well, okay, let's do it. So we like talking, as you guys well know. But what I would like to ask some of the so we're in South Carolina, Charleston to be exact. If any corporations around this area has training facilities, we would like to come and do a tour for you guys and kind of let people know what you offer. We would be open to coming out and interviewing you guys, learn what your end goal is and what you're trying to do in the community. Also, that goes for anyone around the Charleston area, North Carolina, Virginia, Alabama, Georgia. I mean, we're not limited to the South. We can go wherever. So, I mean, if you guys are...
An airport.
Yeah, there's an airport. But also, like Nick said, we're working on some things. We will reveal those things later. It's a lot of irons in the fire. So we do appreciate all the support, and I'd just like to say thank you.
Yep. And also, if y'all see us, you'll probably see me in town. Say hello. We'll be at SEMA, 2024 this year. So come out and see us. We walking around saying hi to people and kind of seeing what's new in the industry. So, with that, I say thank you, and y'all have a good one. We'll talk to you later. All right, bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoyed the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanara Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.